Hey everybody, this is Mr. Mott. What we're going to do is go over the calculations involved with our determining the empirical formula of a hydrate lab. Sounds really fancy, but all we're trying to do is figure out in our hydrate, which was some Epsom salts or magnesium sulfate, we're trying to figure out how many water molecules were attached to the MgSO4. And so what we did in our labs, we heated it up, and what we did is we decomposed it into the solid and then the water, which turned out in the form of water vapor. And what we were trying to figure out was this: how many water molecules were liberated, and also sort of how many water molecules were attached there. Okay, so the data that we collected was the mass of our evaporating dish was 35.51 grams. Um, I added about a gram to the evaporating dish. My total mass was 36.54 grams, and so then subtracting those two, I got 1.03 grams. So that's how many grams of the Epsom salts, the magnesium sulfate hydrate that I started with. At the very end, my mass of the evaporating dish and product was 36.09. And so what I'm going to do now is figure out analysis question number one, determine the mass of MgSO4 produced. So this is our product without the water. So we started out, so our mass of our evaporating dish and our product was 36.09 grams. And I'm going to subtract the mass of 35.51, which is the mass of my empty evaporating dish. And so the amount of product that we had left over was 0.58 grams. Okay, so that's the amount of product I had. Trying to figure out how much water was lost in the reaction, well, I started with 1.03 grams of solid, the hydrate. And I'm going to subtract out the MgSO4, which is, we just calculated 0.58 grams. And we get 0.45 grams. Okay, so that's 0.45 grams of water, and 0.58 grams is the MgSO4. Okay, so we know how much MgSO4 we made, and we know how much water was evaporated off. Okay, so then question number 3 says, using the molar mass of MgSO4, determine the number of moles of MgSO4 made. So we're going to start out, the thing that we know is our 0.58 grams of MgSO4. And what I'm going to try to find are moles of MgSO4. Remember, our abbreviation for moles is the letter N. Okay, clean that up a little bit. There we go. So I'm going to put my units of grams on the bottom and moles on top. And when you're comparing grams and moles, the relationship between grams and moles is always the molar mass, which says for every 1 mole, it'll weigh a certain number of grams, which you would get from our periodic table. So our molar mass of MgSO4 is 120.4 grams. Okay, so my units of grams will cancel. That's how I know I put everything in the right spot. I'm left with the units of moles, which is what I want. And so now, doing my math, 0.58 times 1 divided by 120.4, we get 0.0048. Okay, write that in a little different spot here. 0.0048 moles of MgSO4. Whoops. Okay, that's our answer. We're going to do the same thing for water now. And let's see. So I started out with we determined we had 0.45 grams of water that were in our original sample based on our calculations. And I want to know how many moles of water we made. I'm going to put grams of water on the bottom, so these units cancel. Moles of water on top. It's 1 for every 1 mole of water, it will weigh 18 grams. And doing the calculations, 0.45 times 1 divided by 18, we get 0.025 moles. Okay. So what we're going to do with these two data, these two numbers that we calculated, is compare the mole ratio. And so we're going to take our bigger number of moles divided by our smaller number of moles. Our bigger number of moles is 0.025 moles of water, and we're going to divide that by our smaller number of moles, which is our moles of MgSO4. So the reason we're doing this is we're going to get a number, and it's about 5.2. So it says for every 5.2 moles of water, there will be 1 mole of MgSO4. So the reason we're doing this is sort of we have a cleaner ratio of the moles of water to moles of MgSO4. So going back to our original problem, going all the way up to the top, what we were trying to figure out here is how many moles of water were attached to our MgSO4, again highlighted here, and we're also finding how many moles of water were made. And so according to our data, rounding to the nearest whole number, this value would be 5. So 5 water molecules attached to every 1 molecule of MgSO4, and then this value here would be 5 as well. And so what we kind of figured out from our calculations there is that these numbers that we put in front of these chemicals when we balanced equations actually represent moles. So with this calculation, what our calculation shows that for every 1 mole of MgSO4 H2O5, you will make 1 mole of MgSO4 solid and 5 moles of water. Okay, so that's where our calculation shows us. And I would say if you in your calculations get anywhere between any number greater than 5, I think you had some really good data. The actual number is 7, but it's a really hard value to get in practice because you have to cook the Epsom salts a lot longer than you think you would have to. But I hope this illustrates the connection between the data we collected and how it correlates to our balanced equation. Also shed some lights on what these actual numbers mean. So that's our empirical formula of a hydrate lab. Thanks for watching.